Hey, hello and welcome. My name is Dr. Bethan Davies and I'm going to talk to you today about what it's like to live and work in Antarctica. Now, I'm lucky enough to have been to Antarctica as a scientist 3 times, twice to James Ross Island and once to Alexander Island. Both of them are on the Antarctic Peninsula. So I'm going to tell you a little bit about myself and a little bit about what it's like in Antarctica. So my name is Dr. Bethan Davies and I am a glaciologist. I study glaciers and how they're changing, both how they're changing today by looking at, for example, pictures from satellites and looking at how they've changed over the last 20 to 30 years, but also I look at the landforms that form around the edges of glaciers, and that tells me something about how glaciers have behaved in the past. So when I go into the field to places like Antarctica, I'm really interested in the rocks and the sediments around the margins of the glaciers, because that tells me about what Antarctica was like and what the glaciers were like when maybe the climate was a little bit different to today. This means that when I go into the field, I'm often really far away from civilization. A lot of the places I go are really remote and hard to get to, particularly in Antarctica. This is the Antarctic Ice Sheet. It's right at the bottom of the world, right at the South Pole. The South Pole's right in the middle of Antarctica. It's the world's largest ice sheet and it covers 14 million kilometres squared. Oh, that's a really big number. So to give it some context, you could fit all of the United States of America into Antarctica. The United Kingdom is much smaller than just the Antarctic Peninsula, which is this small part right at the top. So Antarctica is really, really big. It's completely surrounded by the ocean, and you can see that unlike Britain and Europe, which are part of these big supercontinents, Antarctica is really isolated, and that's one of the reasons why Antarctica is so cold. On average, the ice in Antarctica is 2,000 metres thick, and snow and ice cover 99% of the continent. When we look at it from space, it's all silvery white because of all that ice. The thickest ice is nearly 5,000 metres thick, 4,776 metres thick. That's almost 3 miles. It's covered in snow because it's so cold. There's very little melt in Antarctica. If it snows, the snow doesn't really melt, it just hangs around. Eventually the ice flows to the coast and most of the ice is lost by carving icebergs and melting underneath the water where the ice meets the ocean all the way around. There's enough ice in Antarctica, if it all melted, to raise global sea levels by nearly 58 metres, which is enough to flood a lot of England. If we look at where 60 metres sea level rise would flood, we'll lose large parts of East Anglia and London and lots of the south coast of England. So 60 metres sea level rise would really make a difference. That's not very likely to happen though. We don't need to worry too much about 60 metres of sea level rise, but we might see some sea level rise from Antarctica because there's more melt happening around the edges today than there used to be. How cold is it in Antarctica? Well, the coldest temperature ever recorded on Earth was recorded at Vostok Station in 1983, which was a chilling -89 degrees centigrade. At the South Pole, right in the middle of the ice sheet and at 3,000 metres above sea level, the average July temperature, which is summer in the United Kingdom but is winter in Antarctica, is -56 degrees centigrade. And at that South Pole in July, it's completely dark all of the time. The average July temperature, which is the summertime in Antarctica, is minus 25 degrees centigrade. And in January at the South Pole, the sun doesn't go down. It stays bright all day for 24 hours a day, but it's still very cold. It's much warmer around the coast. So on the Antarctic Peninsula, where I've worked, it tends to be around minus 5 to around 0 degrees in the summer, and in the winter from minus 5 to about minus 20 degrees centigrade. It's cold enough for the sea to freeze. And this is a photograph of the Rothera research station in Antarctica. And you can see lots of icebergs behind the research base, and you can see that the sea itself is frozen. Without a doubt, the coolest animal in Antarctica is krill. All life in Antarctica is dependent on krill. There isn't really any land-based animals in Antarctica because all the food is in the ocean. It's so cold in Antarctica that over most of it there's hardly anything growing at all. Just a little bit of moss and things like that right in the warmest parts. But there's very little to eat on land in Antarctica. But the oceans are really productive and they're filled with krill. There's so much krill in Antarctica that all the animals and all the life in Antarctica really depends on it. Fish eat krill, penguins eat krill, seals eat krill, even whales eat krill. And then the predators, like the orca or the leopard seal, will eat the other seals or the penguins or the fish. But everything at the end of the day relies on krill. So krill is really that most iconic and important of Antarctic animals. The penguins in Antarctica are cute, you can't deny it, but they definitely are not as cool as krill. And did you know that there used to be dinosaurs in Antarctica? Some of you have asked, why was it warmer in the Cretaceous? And that's because levels of carbon dioxide were much higher, related probably to things like more seafloor spreading. Antarctica was also not in the same position that it's in today. So it was in a warmer part of the world. It was slightly moved relative to where it is today. So 66 million years ago, the end of the Cretaceous, there were forests in Antarctica and warm seas. James Ross Island, which is right at the northern tip of the Antarctic Peninsula just here, is one of the most important places where dinosaurs have been found in Antarctica. I'm lucky enough to have been twice to James Ross Island, but I didn't find any dinosaurs. This is what James Ross Island looks like. You can see that it's mostly covered in ice, but there are some large parts up in the northern part down here, around here, which are mostly ice-free. And there are good exposures of Cretaceous rocks in these parts of the island. It's all sandy coloured and Cretaceous mudstones and flagstones. And they're full of fossils. One of the fossils that's been found on James Ross Island is this one. It's a medium-sized ankylosaur, and it was found in 1986. It dates from the Upper Cretaceous, and we found the fossils on the northern James Ross Island. And this ankylosaur was a herbivore, and it wasn't so large. Other types of dinosaurs that have been found on James Ross Island are a late Cretaceous theropod that was found on the Naze, which is right at the northern tip of Antarctica, and only small bits of that one have been found. And then an iguanodontid was found in 2002, but I couldn't find any good pictures of it. Some of you have asked me, how do you get to Antarctica? Well, you can see that Antarctica is really far away, and it takes a really long time to get there. The easiest way to get to Antarctica from the United Kingdom is to take an aeroplane and fly to the bottom of either South America or the Falkland Islands. Okay, so that's the easiest way to get south. And that is a long old flight. It takes at least 24 hours, maybe 2 days if you have a break in the middle at Santiago or somewhere like that. So a good long flight. If you go to the Falkland Islands, you'll have to wait for the right weather to cross the Drake Passage. and the Drake Passage is between the Falkland Islands and the northern Antarctic Peninsula. There are 2 ways to cross the Drake Passage. You can fly over it in an aeroplane, which is a flight of a few hours, or you can cross it on an ice-breaking ship, and that takes a few days, and you have to cross some of the roughest seas in the world with huge waves that make everybody very seasick. When we go to Antarctica, a lot of people will go to a research base. One of the British research bases is Rothera Research Base, which you can see has a red star on the map here. And you can either fly directly to Rothera, or you can get a boat, a ship, to Rothera Research Base. And from there, fieldwork parties will be dispersed all over the Antarctic Peninsula. I'm going to tell you a little bit about one of my field seasons to Alexander Island. So here's Alexander Island, and here is James Ross Island, which I already mentioned. When we went to Alexander Island, we took an aeroplane to Rothera, and from Rothera we then flew down to Ablation Point Massif, where we spent a month living deep field, hundreds of miles away from any civilization at all. This is the icebreaker ship that I've used to get to Antarctica. I used this ship when I went to James Ross Island. It's a red ship, and red icebreakers are always red. They've got really strong hulls so that they can break up any ice that is in the way. But mostly it's safer to go around if you can, and we can only break thin ice. You can see that it has a helipad at the back, and then you can see all these windows around the front. And that's the bridge, where the people who steer the ship can see out in all directions. The big round circles, or spheres that you can see, are how we get satellite phone reception. It means that we can occasionally read our emails, but the internet connection is really slow, and you certainly can't stream Netflix or anything like that. You can see that we have a crane, and we have drilling rigs, and we have all sorts of facilities on board the ship. This is the Dash 7. The Dash 7 is an aeroplane that you take if you want to fly to Rothera, and it takes about 20 people or so, and it will land on tarmac runways like we get as standard throughout the world. It can also land on ice runways, so you can use the Dash 7 to fly into the middle of the Antarctic Ice Sheet, or to places like Fossil Bluff, which have an ice runway, so it can even land on the ice. Here is the Dash 7 landing at Rothera, and you can see that at Rothera we have a tarmac runway, just like you would do at Heathrow. And so Rothera has its own air traffic control and its own system for landing the aeroplanes. This is Rothera Research Base. Here you can see the runway, and here you can see the big spheres, which again are how we get our satellite data if we want to use the internet or something. But again, it's very slow compared to what you might be used to. You can see an aeroplane is coming in to land, and you can see that it's still quite early in the summer, and the sea ice is still frozen. You can see there are icebergs in it, and it's still very frozen all looking here. There are some low sheds here, and these are where your bedrooms will be, and you live in bunk beds in a bunk room in Antarctica. It's not very glamorous. And then we've got the bigger building over here, which is where we have the recreation rooms, where you might have the offices, where you have the canteen, where you get your food, and where you have a lot of the laboratories as well. There's lots of facilities here to do science, and we have a number of different buildings here. They all have different purposes. Some of them are laboratories, some of them are equipment sheds, and there's all sorts of things here so that people can survive in Antarctica. It takes all sorts of people to keep an Antarctic research base running. So as well as the scientists, there'll be chefs and plumbers and carpenters. There's 2 doctors in the summer. And there'll be a number of people who are needed to keep everything running. Engineers and meteorologists and biologists and all sorts of different kinds of people. And Another gratuitous photograph of a penguin. There's lots of wildlife around Rothera. It's a busy place. There's seals, there's penguins, there's whales, there's orcas, there's all sorts of little animals, and they're all quite curious and interested, so they might waddle up to you. But you're not allowed to approach them because that would be unfair to the animals. So we keep our distance, even if they come onto the base, which they do sometimes. Once you got to Rothera, you need to go into your deep field. And I'm going to tell you about working deep field on Alexander Island. This is the Twin Otter aeroplane that we flew in. Here are two engineers, and they are about to depart deep field to go and do some testing of some instruments around Antarctica that they're responsible for running. But you can see that inside the Twin Otter, it's rather small. It can only take a very small number of people. It's not very comfortable, and there's not very much in the way of seats and things like that. But you'll load all your cargo and all your kit onto a Twin Otter aeroplane. And these Twin Otter aeroplanes are so clever. They have skis, so the Twin Otter aeroplanes can land pretty much anywhere. They're like the Land Rovers of the Antarctic. They're only tiny, but because they can land on skis, they're nimble, and they can land in all sorts of places. You can see this Twin Otter aeroplane has landed in the middle of the ice sheet. And this is our Twin Otter aeroplane. This is where we've been deposited on the ice near to our field season. We can't be landed any closer because Alexander Island is an Antarctic specially protected area, which means no vehicles are allowed to access it. So we were landed a couple of kilometres away from our field site, and we had to drag on sledges all our equipment to our field camp. Here you can see I was even allowed to fly the aeroplane for a little while. It turns out that flying an aeroplane is easy. You just have to keep it straight. I think it's the taking off and landing that's quite hard. But I had a little go with the pilot watching very closely. You can see this is our pile of equipment. This is all we have to survive for our month of field work. We have all our food, all our tents, all our clothes and everything we need. And we have nothing that we don't need because everything has to be carried. We can only take one lot of kit in the aeroplane, and we need to drag everything to the field camp. So we're very careful about what we take with us. Nothing too heavy. And this is our field camp. You can see that we really are quite remote. In this picture over here, you can see a little orange tent, and then you can see our field tent here. And I was in the field with two people called Mike and Ian. Mike was another scientist, and we were working together on the science. And Ian was our field assistant, who's our expert in safety and mountaineering and travelling on the ice. And he's there to make sure that Mike and I are always safe and that we have all the things that we need to work well in the field. We had one tent between the three of us. As you can see, it's not very big. You can see the sledges here that we've dragged with the tent on, and inside the tent it's nice and warm. It doesn't really rain in Antarctica. It's around -20 degrees centigrade when we were deployed into the field, so it's cold, but it's very dry. And this tent is designed to keep us warm even when it's quite snowy outside. You can see that we've pitched the tent on the snow, and we've put large piles of snow all the way around it, and we've put the guy ropes up so the tent is nice and secure and won't blow away. Because there's no water in Antarctica to drink, we have to cut blocks of snow to drink. So any time that we're in the tent, we pretty much always have the stove running. You can see Ian here has got the stove running. You can see he's in his sleeping bag, or one of his sleeping bag liners to keep him warm, and he's melting snow for us to drink. You can see we've already made one round of hot drinks here. We've got a thermos, a bottle of water that we've made here. But pretty much all the time we're in camp and we're awake, we're melting snow. It takes a lot of time to melt snow. It's quite hard work. So that means that we have enough snow to eat and drink, but there's not a lot left over for other things, and it's a bit cold to do much washing, let me tell you. Here's the inside of the tent. You can see here that Ian is taking notes. I think you can see Mike's foot here. Mike is doing some science and Ian is helping him. We've got the stove running down here. We've got our hot drinks and you can see our 3 beds. We all sleep on sheepskin rugs. We've actually got quite a nice bed. You start with a board, a flat piece of board, and then we have a camping mat, a bit like a yoga mat. And then an inflatable mat, which you might have slept on if you ever go camping, and then a sheepskin rug. And then we sleep inside a double-layered sleeping bag, and we have a fleecy sleeping bag liner as well. So we're nice and warm and snug inside our tent. You can see that we live very simply, but really quite comfortably. Now, people always ask about going to the bathroom. And that is our bathroom. You can see it just there, the little tiny tent. The Antarctic Specially Protected Area, and in fact all areas of Antarctica, are pristine. And it's really important that we leave no trace. We don't want it to ever be visible that we were there. And we don't want to leave any pollution behind. All human waste goes in a tub in that tent. And we take that tub out with us so that we don't leave anything behind. And the plumbers at Rothera really enjoy that job. Here are some pictures of us working in the field. Other parts of Antarctica might be using skidoos or ATVs, quad bikes to get around. But because this was an Antarctic Specially Protected Area, we were just on foot. You can see that we've decided to haul our heavy bags with all our kit in on sledges. And we're walking all over the place, all over to do our field mapping and try and do our science. You can see Ian here, and he's looking out across Ablation Point Massif to the hills on the other side where we're going to go and work. And what do we wear in Antarctica? Here is me in Antarctica on a nice sunny day, a dingle day as we might say in Antarctica. And I've got lots and lots of layers on. I've got my thermal leggings and then my warm fleecy trousers. And then on top of them I've got my waterproofs that go all the way up to my chest. They're like ski trousers a little bit. They come all the way up. And then on my top I've got lots and lots of layers. Base layers, and then I've got some lighter fleeces. And then I've got a thin down jacket, like a puffy jacket. And then I've got my outer coat over the top of that. And I've got a handy pocket in the front in which I've shoved all my field kit. I've got all sorts of things in there. You can see that I have a rucksack on. And in that rucksack, I've got another big puffy coat, another big down jacket in case I get cold. And we have other pieces of survival equipment, like survival bags in there as well as a thermos flask of hot tea, some food, lots of chocolate, and the other dehydrated rations that we might be eating. It's very bright when the light shines on the snow, so it's very important to wear sunglasses pretty much all the time, and we have to worry about being sunburned. So you can see that I'm well wrapped up, and I've got my hood on to keep me warm. Even though it's quite sunny, it's still a bit chilly, so I'm nice and warm. If I'm going to walk on the ice, I'll put crampons on my feet. They give me a lot of grip in case I slip. They're like spiky things on my feet. Or I might use an ice axe to help me if I need to. Okay, I really hope you've enjoyed that. I hope I've answered all the lovely questions you all sent in. And I look forward to seeing you all soon. Goodbye.